Let's finish off this table. To finish it off properly though, we need to understand something else. So underneath where you've got the table, would you make this new little subheading for me? Kinds of data. Okay. Now all the different things that we looked at, right? All the different kinds of data, hair length, heart rate, how long you could hold your breath, even number of siblings and so on. They were all numbers. They were all numbers, okay? So we have a big name that covers this whole area of data. Because you can call these numbers like a quantity, right? We call it quantitative data, right? It can be quantified. You can put a numerical value on it, okay? Now, when you go within numbers, and I'm particularly going to look at group 4, because they did the siblings, right? You will notice that there's more than one kind of numerical data, okay? Most of us have what was called continuous quantitative data. Continuous numerical data. So the idea is that there's range, right? And any value in there, they're all fair game. You can take any value between this and this, and you'll get a reasonable answer, okay? So this usually comes from when you measure things like someone's hair length, okay? However, that's not the only kind of quantitative data, right? You can also have the opposite of continuous, which you might think is called discontinuous, but not quite. It has its own special fancy name. Discrete quantitative data, okay? Not to be confused with discrete with a double E, which means shh, quiet, secret, discrete. That's what that discrete means. This discrete comes from a Latin word which means separate, and they're all, they're not continuous, they're not connected. You can only have certain values. For instance, how many siblings might you have? You might have none, or 1, or 2, or 3, but you can't have 1.5 siblings, or 1.25 siblings. Okay? So, continuous data comes from measurement. Discrete data usually comes from counting. Nathan, question.
Is discrete like disperse?
That's a good question. I don't think it is, but you can look up the etymology of dispersion and go find out. It's possible.
So does that mean medium was better?
I would probably say medium was better. It's not a clear-cut case. You made a good argument for why.
Yeah.
I don't know I necessarily agree with it, but that's my point. See, this is the thing, right? It's up in the air. Okay. Let's move on. Now, this is where we're starting to connect to this. Okay. You can probably imagine there's not just quantitative data that you want to know about people that you can put in terms of a number. Okay. The other kind of data is called categorical. Okay. Categorical data. The short way of saying it, of understanding, is it's any kind of quality or attribute or value that you can't say as a number. You need words to describe it. For instance, your favorite color, right? What's your favorite color? 35. No, that doesn't make sense, right? You'd have to name something. You'd have to use words, categories. Okay. Now, just like with quantitative data, there's more than one kind of categorical data. If I said colors, for instance, okay, that would be called nominal data, right? It has a name to it, right? There are words there, and there's no inherent order. That's the important thing. Which one comes first, blue or red? Well, it kind of doesn't matter, does it? You can put it in any order you like. The opposite is ordinal categorical data.
So what does the first one say?
So nominal, N-O-M-I-N-A-L. Okay. So things like, I'll give you the example of colors. Okay. Nominal categorical data, it's words, but you can't order them. Ordinal, as the name suggests, there are some words that can be ordered. Okay. So for example, I'll give you some letters and I'll see if you recognize them, and they're in a specific order. Okay. Yep. Oh, what's the next one? I wrote it down just so I make sure I got it right. There we go. And then hopefully you never see that one. Does anyone recognize where these letters come from? You see them about twice a year. These letters appear on your reports. right? This is part of the personal profile. There's some categorical data there. These stand for words. Do you know what the words are?
Yes.
What does C stand for?
Consistent.
Consistently, U for usually, S for sometimes,
Oh, no.
R for rarely, N for never. So there's an order here, right? The order matters, right, Sophia?
Yeah.
Yes, it really does. Okay, so you can see here, they're still words, they're not numbers, but there is an order to them. So now I wonder if you can answer for me, what's the advantage of using a mode? Why would you ever use the mode? When is it handy? When is it useful? Any thoughts? Thinking about what we've just looked at over here. Well, let me ask you this, since no one's jumping up and down. If we had some of these, right? Like if I asked you to go and collect favorite color, okay? Or I looked at all of your reports and we looked at all the different outcomes that you received, okay? Which one of these would be the best measure of central tendency, right?
Median.
Well, for instance, suppose we went color, and I said, well, I like taking the mean. I like taking the average, okay? What is the average of colors? Or how do you rank them, right? Or what would be the middle color? Does that even make sense, right? So when you've got words, you have no choice really but to use the mode, okay? So the key advantage of the mode is that, wrong color. It works with categorical data. Whereas you cannot really effectively use the mean or the median if you have words for your data. Okay? So it works with categorical data. The average favorite color is what, grey?
Yeah, that's what I'm saying. So, like, let's say
Which is, but not, that's not very meaningful, is it?
Oh, sorry. Yeah.
Okay, all right. I'll give you quick two disadvantages. Under here, there's more, but it just gives you a general gist. Number one, and you might have a look at your data. Okay, you can find out. No surprises to find out that the function in Excel to find out the mode is equals mode, right? No surprises there. Okay, but the problem is sometimes there isn't one, right? The mode might not exist. Because, for instance, let's think about hair length, right? How likely is it that you've got people in the class who have exactly the same maximum hair length, right? Not very likely. It's possible, but not very likely, okay? And secondly, it ignores a lot of data, right? I'll give you a quick drawing, which I'd like you to sketch up just on the side of here to illustrate this, okay? Suppose we had a graph of, let's do hair length, okay? So I'm just going to make up an imaginary class, okay? And this is, hold on, wrong way, sorry. This is how many people? This is people. And this is hair length. Okay, so you got longer hair going this way, shorter hair going this way. Okay, there's a whole bunch of number of boys, right, who have relatively short hair. Okay, so suppose this is say 10. Okay, and you got 10 people up here, right? But then you have a whole bunch of girls, and we've got hair sort of one person here, one person here, one person here, one person here, one person here. Okay, now when you have a look at this, where is the mode? It's really obvious where the mode is, right? It's all the way over there on the left for whatever short length of hair this is, okay? How much has the mode taken into account all of those girls up the top end with really long hair? Answer,
It hasn't.
not at all. Completely ignored them, okay? So therefore, that's kind of a problem, right? The mode can get thrown off in a similar way that the mean can, so you have to be careful with it, all right?